Hey folks, my name is Dave. Welcome to the NTD Racing Fab Shop. Behind me is Lefty. This is the trophy truck we're trying to build and get ready for the Baja 1000. We'll be close. But if you've been watching along, I cut all these tubes at Bentech. We designed it using their Bentech software. We used their Dragon 400 machine to cut all 115 tubes, and we're in the middle of fabricating, putting this thing together, but we're gonna take a pause to get the engine into what I call the engine cradle. So today will be all about building the engine side and also the frame side mounts for this thing. So what I'm gonna show you is the parts that I'm gonna use, how we're gonna pull the dimensions off of the engine, put those into Fusion 360, and then take that over to the Langmuir Systems CrossFire XR to cut out those parts and start welding them all together. So today we're working on those front engine mounts. And then on the next episode, I'm gonna show you how I make a really robust transmission mount for this 6L90 transmission. Let's go ahead and check out what we'll be using today. All right, where to start with this conversation? I guess we'll just start with first the engine. And the trick, I think a lot of times, is just figuring out how are you gonna lift one of these engines. And so I'm constantly designing different things just to lift the engines. And you'll see in some of our previous videos, I take the exhaust manifolds off and I bolt some plates up to the side, and then these chains mount to the center. But today, I'm trying to leave those exhaust manifolds on to see if I can later on. And then I just got it mounted up a little bit differently with some pieces that I cut off the CrossFire XR. These are 1/4" plate bolted on the sides of the heads. Now, those chains go up to this bar that I made a while ago. And to basically now connect that whole system onto what I'm gonna be using to lift it, which is my lift here, is I'm gonna make this bar to go across the arms of the lift. And these are just some scrap parts, pieces I had in a bin that I'll be using to make that, and there'll be a lift. And this thing will connect onto there to lift the full engine. And I'll use both arms basically to balance and level the engine. You'll kind of see how I do that. I'll be using that to set the engine into the cradle and then dimension everything to make the engine mounts. Let's take a look at what kind of engine mounts we'll be using. You kind of get a little sneak peek of what we're doing in the rear for the transmission mount. But the engine mount, which we're talking about today, will look kind of like this Frankenstein engine mount right here. It'll come down to the cradle frame, and then it'll go up to the bolt to the side of the engine like all LS engines have. And I'm pretty sure that's a pretty standard bolt pattern. I'm gonna pull more accurate dimensions off of that, and we'll make another one of those. But what I find is that a lot of the stresses kind of go on where that plate mounts the side of the engines. The bolts can take it, but I have sheared off the weld all the way around. I've used a little bit thinner material. This time we're using 1/4" plate, and the upright we're going to be using also will be a 2" square with a 1/4" wall. And that'll be pretty robust on the engine side. And then on the frame side, we're going to be using these bushings. So there'll be a little bit of give, not necessarily as much stresses on the frame side. I get these bushings, they're just either 67 to 87 shackle bushings from a Suburban. And there's the part number if you're interested in something like that. And what I like about that is we just continue using the DOM that we use for the rest of the truck, the 2" 120 wall DOM, and that's what those things will sleeve inside. In the past, while I've made these, you know, I kind of put the bushings inside the piece of DOM that I have, and then as I'm welding it, I've got to do some tack welds and then really quickly try to cool that thing down because it'll start melting the rubber that we're using for that. So what I made, I don't have a really cool lathe or anything like that, but I had a bunch of extra tubes sitting around, so I was able to make these slugs, I think we call these things, just basically from sleeving tubes inside of each other until I get the right size. And so those go in there, and now when I'm welding, they won't melt. And then inside that goes this the sleeve, which is this sleeve right here, will go in there, and then I can put my 9/16" bolt all the way through there. And I can basically mock it all together, weld it completely before I take it apart. And that makes that really handy. So anyway, let's go ahead. I'm gonna put this thing on time lapse and you can see me making that mount and then trying to get this engine into the cradle. Let's get to it. All right, here is the engine in the cradle, and I think it went in perfectly, pretty happy with it. Let me show you some of the high-tech tools that I'm using to get it all lined up. So I got this square lined up with the center of the cradle, and basically to align the engine up in the center, I'm just basically taking the plumb bob off the water pump and through the crank there, and it's lining it up on that, and it's pretty darn close there. And then as far as getting the engine level left and right, I haven't found really a much better way other than to put my little angle cube back here on the valley cover, and there you go, within 3/10 of a degree. And then as far as, front to back longitudinally, how far I like the engine to be, kind of 5 degrees is what I've been using we use on Honcho, and that's pretty close there to 5 degrees is how much the engine is tilting down at the tail. Now, why do I do that? The reason I do that is because, we are using, people will scoff, but we've raced already twice at the Baja 1000, haven't blown one of these up in Honcho, but we're still using a slip yoke on this thing. And then there's only just so much travel that you get out of these U-joints. This will not be the one that we use. We're gonna have the guys over at Oceanside Driveline build us a new drive shaft. So these won't be the ones we use, but this is the hardware. This is basically the equipment that we do use. And there's a limit to how many degrees it'll go up and down. So this will basically allow our drive shaft to go 10 degrees down and then be at the 0 point. Because usually our limiting factor as far as where we strap our suspension in the back is how far these U-joints can handle going down. So anyway, you kind of get an idea of the setup. What we have here, we're gonna have the exhaust. Where we had it before, we had it kind of coming out and going all around the side of the car. Now we're gonna have it going down and going inside the cradle there. And then the other side, we'll have our coolant lines going down the cradle also with the exhaust. So we'll be dealing with some heat issues. We'll see there might be a shield on both sides there for the driver and the passenger, and then also for the transmission, but there's plenty of room in there. I mean, it's a huge vehicle compared to Honcho in every respect. It's got so much more room. So I don't think we're gonna run out of space. So, all right, so now that we have it in there, let's talk about what these engine mounts are gonna look like. First, let's take a look at Honcho's. All right, we're looking underneath Honcho now. And what you see is here's that same 1/4 inch, 2-inch square tube there. Kind of goes all the same hardware. But what you'll notice here, which I'm gonna change on this one, is that this perch just really isn't that tall. And what that makes happen is the actual shaft here that becomes the engine mount. I'm not sure you want to call that, but the actual piece there is long, which means that over a long distance, you can create a lot of moment arm. With that in mind, let's go ahead and take a look at Lefty. All right, so I bolted that plate in there, and as it turns out, that plate, which I didn't think was gonna fit perfect, it fit perfect. I'm just gonna cut another one of these out on the plasma table and be good with that. But you can see the distance here is probably 12 inches from that plate to here. And I'm gonna probably bring this up about 4 inches just to make that distance that the rotating piece there of the engine mount has gotta be shorter. And that will reduce the moment arm. And just like putting in the 1/4 inch plate will be another way to lessen the likelihood of that thing breaking. And then also making a more robust transmission mount is also going to help with that. I think that we will not have any problems with mounting this thing. So with that, let's go ahead and start building this piece right here, which will be the frame side perch for the engine mount. And then we'll figure out how to connect those things together with some of that 2-inch square tube.
Okay, here we go. Dave's brain on Fusion 360. Let's start with some sketching. And big picture, I think I'm going to make the perch about 3 inches above the base is where I'm going to start with. So we'll make the base first, and then we'll make the other parts later on. So I'm just going to work right off of the center, and I'm going to start with the hole. I'm going to say hotkey C, which will give me a center circle. And the bolt diameter, it's a 9/16, and it's about a 5.55 inch or somewhere in there. So I'm going to go 0.56 inches. All right, and then now how big in the radius around that, I'm going to say hotkey C again, and I'm just going to say this thing's going to be 2 inches. That's the same size as the whole thing that's going in there, so it just makes kind of sense to me to do that. It'll also make sure that it always kind of fits in there as I kind of make the other parts here. So from there, the base of it, how wide do we want the base? Well, remember we said we want it 3 inches from the bottom. So I'm going to turn on construction lines. Anytime you use construction lines, it draws a line, but when you go to cut, it's never going to try to cut that line. So we'll say this thing's going to be 3 inches tall. And then, you know, the base, let's just make it no more than any of the dimensions anywhere. 3.5 is kind of where you can, that's kind of like the weldable flat space on any 4x4" tube, which is going on. But I think if we just go with 3, we're not getting excessive. So I'm going to say hotkey L, which gives me a line. I'm going to turn construction lines off, and then I'm going to go over here. I'm going to make a 3-inch line. And I want it to be centered on that point because I want it to be pretty much symmetrical. So I'm going to say midpoint. I'm going to make that point right there centered on that point. Now that's a constraint that's in there. From there, I'm going to hit hotkey L again. I'm going to go from this point down here until it snaps to where you see that little symbol up there telling you that it's tangential. And then I'll make nice, it'll be a smooth arc going in there. Boom. And then from there, I'm going to remove the sides. And that's kind of this, that's the perch. That's where it's going to be mounted to. That's the thing that's going to be sticking up on the side. Now I want to support that, so I'm going to kind of box this thing in. So I'm going to put some plates down the side just as a box. Now, so I need to make 2 of these. I'm going to actually extrude this part right now. And say hotkey for extrusion and 0.1875. I think that's 3. I think that makes a piece that is 3/16, which we'll be cutting into. So there we go. There's one of those. And for each side, I need 2. But I will just say move. I'm going to say bodies. Click that. I'm going to create a copy. And I need to make 2 of these. And since I'm going to nest these things later, but I might as well start now. Flip it 180 degrees. And then when I go to cut it, I'll just do like that. There we go. Now those 2 pieces are ready to be cut. Now I want to put some plates on the side, like I said, to box this thing in. The full width from inside to inside is 4 inches wide. These plates will go up the side. So I'm going to say sketch. I'm going to sketch on this plane again. I'm going to use this piece just to kind of measure how long that thing I got to make is. And I don't want to go all the way to the end of the hole just because it will kind of interfere with being able to drop this thing in there. So right about there is probably good. And it'll give you enough structural rigidity, I think, for this thing. It looks like a 2.5 inch. So I'm gonna go over here now and make a rectangle. And I'm gonna make that rectangle 2.5 by 4 inches. And let me just make that 2.5 tap 4 just so it makes a little more sense what I'm doing. Now that's the piece that's going to basically weld down the side, and that'll just basically give it some rigidity. But remember, like, this part is going to be open, so every time you wash, this thing's going to fill up with water. So I kind of need to make a relief right here for just so that water can kind of flow out of this thing. So that grabbed the center point, if you could see that. I'll say I'll make that a 1-inch circle, and then I'm going to trim all these parts of the circle. And then I can kind of go in here and I can make a radius on both sides just to kind of soften that up, make it look like you knew what you're doing. And say enter on that. And I can probably do also this. These parts will weld down to the base, but I'm going to do, I didn't want to do that. Control Z, I'm going to make a radius there and there. I'm going to say I want that to be, yeah, that looks about right. Just so it looks nice and clean. There, cool. That's how that will look. And I'm going to say enter on those. I'm going to extrude that and extrude that. And that's going to be 0.1875 for 3/16. And I need to create a copy of that. So I need 2 of these. And it looks like maybe just up here would be just as good. Sometimes you got to scroll in to, otherwise it'll be moving like by 1/2 inches at a time, and you don't want it to do that because it wastes a lot. So if you scroll in, it'll allow you to move it at a lower increment, if you will. So there we go. All right, and then the last piece is, so this is like the sides. These are the braces on the front and the back. And the last piece is, I kind of want to take the place where those 2 4x4s join, and I want to strengthen that a little bit. Then also give these things like a base to basically allow me to weld to. So I'm going to make another part right here, and I'm just totally freestyle on this. I'm going to start drawing. And first thing, I'm going to use just some construction lines. So I'm going to turn construction lines on. And the way that mine goes together, if I have a rectangle, and just say that's 4 inches wide by, it doesn't matter how long, this is like longitudinally front to back on the car. And then I'm going to hit hotkey R again. I'm going to start here. And then now it's like 4 inches tall, tab, that's going to be 4. And then this is going to be somewhere underneath the engine is where that ends. And that's what this thing's going to look like as far as like this plate over here is going to sit on top of this one. And then now what I want to do is I got to keep everything about a 1/4 inch away from the sides over here. And I can kind of illustrate that. I can also go pick a center rectangle again, and then it'll snap to the center point, and I could just, that's not what I wanted. I want a center rectangle. I use this one all the time. I find these really handy. Snaps to the center, and then I could just say that the width is 3.5, and then there it goes about to there. And then maybe that helps me figure out how close I want to draw the next lines. I could do the same thing over here and say tab 3.5. You just got to kind of keep track of what you want to. So like I wouldn't want the thing I'm going to make to go exceed these lines necessarily, just because this is going to be the area where I'm going to weld around the sides. I'm also going to give myself some places to do some rosette welds to really kind of strengthen this thing and lock it into the top of these pieces of metal. So I basically want to make kind of like an L bracket. I might actually have it come all the way down here, just give myself a little bit of room here to weld to, and then weld from underneath. And then it'll give me a perch to put this other part. So we know that this piece right here is going to be 4 inches by about 3 inches, right? So if we take our square and just say rectangle, and it's going to be, probably right about here, just give or take. And I'm going to say that it's going to be in that direction. It's going to be at 3.5-ish. It actually will end up being by 4. Now that's going to be like the base of this rectangle is this one right here. And it's kind of getting hard to keep track of where they are. So I got to build a plate that is bigger than that. So, I can actually just come in here and just start making some lines and just make it up here. Come out to over here, and then maybe come into right about there, across this line. And I don't know why I'm doing this, but I need to make these not construction lines, otherwise it'll never cut them. And making this big enough over here will give me some room to kind of move that piece around. This will be a little bit of space to weld across on the top. I'll get a good weld all across here. And then all the way over to there. And then now you can kind of see this plate right here represents the engine mount. And I can kind of, move it all around here once I get this other plate on top of here. Once I got this, we can just go now and try to make it look like we knew what we were doing, which half the time I can't say I do, I'm just making it up. We can just kind of soften all the lines. I don't want that. I want grab this, grab that. No, not that line. All right. So I have that there, and now what I can do is just kind of, if I want to, I can put some circles in here that I can just kind of rosette weld, just to really tie these things together real well. So, for lack of a better plan, try to make it look good, I guess. I can go. You're going to do it. Might as well do it right. Center rectangle. I'll go from the center here. Escape. All right, that should tie everything together. I got a weld down there, and I got a couple of rosettes. That's going to make a really strong corner there. I'm going to hit hotkey E. I'm going to grab this thing. It all looks the way I want it to look. 0.18875. I don't know. That might not be what 3/16 is. It really doesn't matter at the end of the day. All right, so there's that corner piece. So I'm going to cut all these pieces out. So I'm going to move this one, and I'm going to make a copy. Rotate it again 180, and I'll just put it right here. Looks like the best way to nest that. All right, now we can go ahead and manufacture. So these things, I'm going to make these 3 separate files when I go to manufacture these things. you know, I can kind of move them around and see pieces I have left on the sheet. But this is, I think, a pretty good way to nest these things. I'm going to go to setup. I'm going to say select. I'm only going to select the pieces that I want to cut in my first setup. And I will call these supports. Support plates. And okay, and now I'm going to go to the cutting. So I use the Razor Weld 45, and I love the thing. I've been using it for like, I guess 2 years now. It's how long I've been using Razor Weld 45s. And I said for a long time, as soon as I am let down by the Razor Weld 45, I'm going to get a hypertherm. Never happened. So I'm going to do a lead in, let's just call it at 45, and let's do a lead out. I'm making numbers up here, 65. I want it to go lead in slow, cut at 55 inches per minute, and whip itself out at about 65. And I think that should work out pretty good. So from there, I'm going to pick the pieces that I want to cut. I'm going to go all the way down here to the end. And lead in radius, you know, 0.05 seems like it's been working pretty good on 1/8 inch steel. I'm going to come in at a 90-degree angle for the cut. And then as far as the lead in distance, in general, you want to kind of make that as long as you can, because you want that thing to be totally established in cutting before it hits the part that you're going to cut. And, you know, almost 1/4 inch is probably going to be good enough. So, and then as far as like where I'm going to cut these things, it depends on what I'm doing. Since these are kind of like some corners up here, I might do it there, but you know, this piece down here really just doesn't matter, right? This is just where water is going to exit. And I don't care if it gets a little nick right there. So I'm going to go ahead. I'm going to make sure I'm cutting on this edge. I'm going to do this right here, because what that'll do is it'll make the thing fire the torch here, go in and start cutting. And all this is like wasted material anyway. So I won't be like wasting more material in there. So this piece, I just don't care really if there's a nick on there. So I'm going to say okay to that. Cool. And there's the tool path it generated. So I can go to simulation if you're interested in seeing how this thing is going to cut this thing out. You can kind of watch how the plasma cutter is going to do its thing. You can also zoom in, and there you can kind of see your lead in and lead out and those kind of things. So just some information there, because maybe your lead in and laid out, the reason this be useful to look at is maybe it is too close to something else. Like maybe it leads in like right here, and then like it leads in and follows this contour, and then it burns this part like 2 or 3 times as it leads in and leads out or something. So I've had that happen before, and this seems to be pretty reasonable, and it's also in an inconsequential location. So I think that's a good file there. So let's go ahead. Oh wow, they changed that up. Let's go ahead now and post the G-code. All right, and hit post, and then we'll do the same thing for the other parts. All right, so as I create a new setup, I'm not sure why it does this, but it doesn't let me deselect these. And if there's somebody out, this is something new that they changed on Fusion 360. So if somebody knows how to fix this, please let me know. But anyway, my only workaround for this is to get out of the setup mode there and then just completely delete the setup. And then by deleting the setup, I can go back over and just redo a whole nother setup. And the problem with that, the only reason that's kind of inconvenient is that it makes you redo the whole tool all over again. So that's just a little bit of a bummer. Anyway, I'll go get the box point. I always start at the top left, work my way to the bottom right. And we'll call these the tabs. And you'll kind of see as I go into cutting, it's like, you got to pick your tool all over again. And here's another thing I don't know how to do. If somebody knows how to do this, is to make it to where the Razor Weld 45, I can maybe just say, click on Razor Weld 45 for 1/8 inch, Razor Weld 45 for 3/16, as opposed to having to go in here and put in the values every single time. 45, 65. Because sometimes I can't remember what values I use. All right, all that looks good. We got all those parts in there. Let's take them down to the CrossFire XR and cut some parts out. Okay, before we get started cutting on the CrossFire XR, which this thing is,
I'm going to answer some of the questions I get all the time. Just yesterday I was asked, do I use water or do I mix anything in with my water table? I use straight water. I know it looks like it's a mess right now, but I actually put this in over a week ago, and I went on a trip. I was gone for 5 days. So this water has been in here a couple days, so I'm draining it after this one. How is the water table doing? I have no leaks whatsoever. And if you saw my video about modifications I did on my table, I put the water lines underneath and I run them out, and you can kind of see that makes it really easy to drain this table. And I've got no leaks. You can see underneath there, there's been no leaks. It's been on there, water's been in there for over a week now. No leaks coming out. How do I like the table? I love this table. It has been working great for me. I've had no problems. I don't see any wear issues or anything else that gives me any kind of concern. Everything is working out really good. A testament to this is, and I'm maybe I'll toot my horn a little bit here, but I have been an affiliate for Langmuir Systems. This is kind of cool. I recently passed like $500,000 that people have clicked on my link, and it's been valued at more than $500,000 in sales of Langmuir Systems tables. What did that translate into for me? Basically, it paid for the shocks for our new truck, is what I've gotten as an affiliate out of that. But not a single person has written me and said, hey dude, I bought the table based off of your recommendation and I hate it, I want my money back, or something like that. And there might be somebody out there like that, but in general, if you just put the table together the way that it says, and don't try to be too creative, it works. It is just a really good table, and I haven't had any problems with it at all, besides maybe every now and again having to reset the computer. But besides that, you know, it works, and it's just a really great table. Let's go ahead. I'm gonna start by cutting some 1/4 inch plate, and then we'll get the 3/16 up here, and we'll cut some 3/16, and let's check out the cut quality and see how it does. All right, these things came out great. And this is how it's all going to go together. You can kind of see what that structure is going to look like now in there, and the engine mount's going to come straight off of here. Besides that, you know, how else do you do this? How do you make these parts just so cleanly and so accurately, so quick? I've always been impressed with this table. Let me show you what I do to prep these things to TIG weld.
All right, I've been using the same vinegar for months now, and this stuff is just so nasty. So right now I have the lid off. I'm letting it evaporate off. But besides that, this is what I do to get things ready to TIG weld. This might sound like a big commercial, but you see how easily the mill scale comes off after about 4 or 5 hours in the vinegar bath. This is me using a wire brush. And making this a commercial, all the tools that I'm using here you can find on our Amazon page. I'm an affiliate with Amazon. And if you go to NTD Racing, there's a link right there for how you get there. So right here, I'm using my angle grinder with, I think, a really cool tool by 3M, which is called a bristle brush. And I use this to get rid of all the rest of the stuff and make it really super shiny metal. And it just takes a couple seconds with the bristle brush after the vinegar bath. And that thing is on there. And that thing lasts so much longer than a flap disc and those kinds of things, as long as you're careful with it. This is me using my die grinder to basically open up the holes a little bit. Another great tool by DeWalt. Everything I have that's DeWalt is just amazing. And then also right here is my belt sander. Any part that your hand might touch, I usually round it off and soften those corners up. And anything I'm going to weld or TIG weld, I square the corners off. Besides that, I love getting all these nice, super clean parts now and start to assemble them and get them ready to weld. So here's me doing a little bit of TIG welding.
All right, so I got these mounts located in here. They're just kind of free floating in here, and I'm lining it all up. What I did is I found the difference, the angle from this plate to here is about 22 degrees, and then the distance from the center here to the plate is 6 inches. So now I'm gonna transfer that over to the piece of steel that I'm gonna cut. I'm gonna leave these things kind of floating because what we'll do is we'll line them all up, and these may twist a little bit because remember the engine is canted 5 degrees back. So to line everything up, we might have to rotate these mounts in relation up here. So I won't actually tack those things up until like the very end. Looking at this square tube though, you can see here is the radius that will be where this tube, one of these tubes will be over here. And then 6 inches to that 22-degree cut right there, and then the other radius. So I'm gonna make 2 of these right now. They'll be the exact same pieces. And why does this not go all the way to the end? Because when you put this thing up on there, and you go to weld it, it gives you a piece to weld to. And if you made it halfway, then you have a little sliver right there. As I go in with my tube notcher, it's gonna leave a little lip right there. It's gonna give me a thick piece to weld to right here. So all the way around, I'll be able to get a really solid weld to this tube. Let's go ahead and get this thing cut out.
Well, now that I know what is possible at Bentech, I sure wish I had my own Dragon because this would go a lot quicker. But anyways, the bandsaw I've had that also on my Amazon page. Just amazing. That thing will cut through anything. I've cut through 7 inches of steel before with that. It's a pretty amazing tool. And then, every now and again, you got to pull out your old notcher. Again, Bentech would have made this a lot easier, but the notcher is still pretty good.
All right, let's fit it in there. Let's see how it goes. Lean right up. First off, pretty close on the first try. Now what I can do is I can kind of rotate the plate left and right, and then maybe in and out, just until I get the best flush fit over here to the plate that's on the engine. Once I've got that, and I'm pretty happy with the location, everything's centered up, and it's exactly where I want it, what I'm gonna do is I'm gonna go ahead and take this tube right here. I'm gonna completely clean it up, get it ready to weld, and get this piece ready to weld. I will put some good tacks all the way around on these pieces. I'm gonna pull this whole thing out. We'll go ahead and finish weld this whole part right here, the mount, and then we'll put it back in, and then we're gonna go ahead from there and put some good welds down here on this base plate, some good tack welds. I'll just tack weld it here because later on what I'm gonna do is I'm gonna pull that engine out. I'm gonna raise this thing up to somewhere where I can be really comfortable and put some really good welds on this thing also, and finish up all the rosette welds and all the edge welds and all those kinds of things. So we will do that later once the engine is out and no longer in our way. But what we're gonna do next in the next video is start tackling this transmission mount. All right, well, I'm really happy with the way the engine mounts went in. Super easy to do and cheap, especially if you have cool tools like that Langmuir Systems CrossFire XR. Again, if you're interested in one of those, you can check out more information by going to ntdracing.com. There's a whole playlist on our YouTube channel, and using code NTDRacing will get you $100 off if you're interested in buying one of those tables. But next, we're gonna try to complement those front suspension mounts with a transmission mount, which is a little bit more robust. And we're really gonna try to tackle what I think is just another one of the weak points of the 6L90 transmission, which is that fragile tail housing. So we'll be using some extra couple of bolts to kind of tie in and maybe give that tail housing a little bit of help from the main case of the transmission. And if you like that kind of stuff, then maybe you'll consider hitting the like and subscribe, ringing the bell for notification of future episodes like that one. And we'll see you on the next episode. Take care of yourself.